G'day there. I've decided to make the Year 10s a video. The Year 10s have been very quiet, and I was always told to watch out for the quiet ones. So I'm going to make this for you. I'm going to revise something that we did last term, but it's obviously something that brings people a lot of agony because it involves needing to pull together a few different skills. Essentially, our goal here is I'm going to go through how to find the exact value of certain trigonometric function values, things like tan 60 or cos 120. And before we do that, I need to review identity triangles with you. They were two special triangles that we use to find the exact values of sine, cos and tan for 30 degrees, 45 degrees and 60 degrees. That's what we use it for. So there was a 45 degree one and there was a 60 degree one. The 45 degree one looked a bit like this. If one of them's 45 degrees, the other is 2, and we simply assume these lengths are 1. How long does that make the hypotenuse? If you pause now and think for a while, you should be able to tell me. If you don't, I'll be very sad. Anyway, it ends up being the square root of 2. Right, the second one, the 30-60 identity triangle, is actually it's an equilateral triangle cut in half. And this equilateral triangle had side lengths of 2. So every side's 2. What does that make half the length? Should do that to make sure you see it's equilateral. So half the length of 2 means that side's 1. I should mark in the 60 and the 30. 30 being the smaller angle, 60 being the bigger one. And what does that leave the last sign? Again, if you mute, pause for a little while, you'll find that this side length here has to be root 3. Now that allows us to find the exact values of sine, cos and tan when you're dealing with 30 degrees, 45 degrees and 60 degrees. So, for example, we'll do a couple of examples. We did up a big table back in the day and worked out all of these exactly. If I asked you tan theta is opposite over adjacent, I'll start with the rule. And if I then said, well, what's tan 45 degrees? I'd look at one of my 45 degrees here, and I'd think, well, opposite is 1. So opposite is 1, and adjacent to that 45 is also 1. And thus you can work out tan 45 is 1. You can put it in your calculator to check, but in mathematical methods, you need to be able to do that by hand. No calculator. So I'll do a second one. Let's say I did cos 30 degrees. I'll do the rule for cos first. Cos theta is adjacent over hypotenuse. So in this case, if I said cos 60, I look at the 60 degree triangle here. I'm only looking at the triangle on this side. That's our 30-60 triangle. I only have the other bit because I was showing you how to construct it. Right, if I'm looking at the 60 degrees here, adjacent is 1, the hypotenuse is 2. Cos 60 is therefore 1/2. Sine 60 degrees, we'll do a sine one. Sine, of course, is opposite over hypotenuse. So if I said sine 60 degrees, I'd be looking at the 60 again, except this time opposite. Opposite is root 3. The hypotenuse remains 2. Cool. So there we go. That's the identity triangles, and that's how to use them to find exact values. However, where this gets nastier is exact values for any angle. In which case, our world gets a lot more complicated and you need to remember a lot more of what we did last term. This is not a matter of shoving stuff in your calculator and hoping for the best. Right, I am going to demonstrate this whole process with, I think, cos 150 degrees. First step, always draw a diagram. Yes, you are going to draw a unit circle. Do not get fazed by a unit circle. A unit circle merely means that you are doing a circle which has a radius of 1. Unit means 1. Unit circle means radius 1 circle. So you would draw something like this. Okay? Now, I'm going to draw 120 degrees. You also need to remember that in this variant of trigonometry, this is 0 degrees, this is 90. So it goes, what do we call that? Anti-clockwise. Anti-clockwise from the horizontal. Right, so this here becomes 180 degrees, this here becomes 270 degrees, over there again would be 0. All right, you need to do it. That is different to bearings. People get those two confused. Bearings starts at north and goes clockwise. Trigonometry starts at 0 horizontally, goes anti-clockwise. Very different. Keep them distinct in your mind. This business we're doing today, we're all starting at 0, going anti-clockwise. Cool? So 150 degrees, it's going to sit over here. Now the technique I use here may be a bit different to what you see elsewhere, but it works beautifully. 2. Draw a triangle with the x-axis. So in the case here, to draw a triangle with the x-axis, I'll draw a line down. Right? Forming a triangle with the x-axis. Right? One of the lines will be along the x-axis. The angle there, you should be able to tell me, is 30 degrees. Right? We're at 150, which is 30 off 180. Now, this is a bit different to some of the other strategies. What I do right now is I essentially put identity triangle values on it. So this here, which identity triangle do you think I'm going to be working with? Am I going to be working with the one that has 45 degrees in it? Or am I going to be working with the one that has 30 and 60 degrees on it? Given we already had 30, big hint, it's going to be 60. All right, so 60 degrees goes here. Remembering our triangle, the long side is 2. The short side is 1. The other side is root 3. I've essentially made our identity triangle in the diagram. All right, next step is find value. Now, so in this case, I said cos 150. Cos theta is adjacent over hypotenuse. Cos 30 degrees, because 30 degrees is the angle here. Cos is adjacent over hypotenuse, so it's going to be root 3. Adjacent's root 3. Remember, looking in the context of 30 degrees, root 3 over hypotenuse, which is 2. Now that gives us cos 30, but we're actually after cos 150. So essentially all you need to do is check your sign for the final answer. So if I was doing that, this is where you need to remember. All stations to central. There's all sorts of different ways of remembering it. Heck, what did I just say? I did say all stations to central, didn't I? All right, remember how we did this diagram that showed where everything is positive? Remember this? The A means that sine, cos and tan are all positive in this quadrant. The S means only sine is positive in this quadrant. That means that only tan is positive in this quadrant. That means cos is only positive in this quadrant. And you had to remember that. I used to remember it by cast, which is why I wrote the C that early. You're casting a fishing line. Go over, right? Cast. You can read the word. Some people used to remember it as all stations to central, and I'm sure if you look on the internet there are probably a series of much weirder and less appropriate ways of remembering it if you've got an issue in that area. So the important thing here is we were looking in this quadrant, the second quadrant, and we're looking at cos. Is cos positive or negative in the second quadrant? Cos is negative in the second quadrant. Therefore, the only thing we need to change here for our final answer, cos 150 degrees is going to be equal to negative root 3 divided by 2. Now, that's your exact answer. If I were to put that into a calculator, I would get a decimal answer. A decimal answer isn't exact here because it will involve rounding at some point. Exact with the square root, not exact in decimal form. Now, just for fun, I am going to put cos 150 in this and show you what you get. Actually, my calculator does exact values, and that's probably why it's not allowed in your year 11, 12 exams. Anyway, a lot of people would have written that, negative 0.866. out of your calculator. That's not what we're asking you for. We're asking you to do a serious, considered activity here to find the exact value. Do you want a second example? Should I do a second example quickly? I might do tan 240. Make sure you've got what you want down here because I'm going to get rid of it. I'm going to start our diagram again. I'm going to do all of these bits again, and right. Second example can be, and I'm going to do this one fairly quickly. The second example can be tan 225 degrees. So in this case, 225 degrees, it's between 180 and 270. I'm going to draw a line out here. That's my diagram. Secondly, draw a triangle at the x-axis. I draw a line up, I make my triangle. It's 45 degrees past 180, so it's going to read 45 in there. All right, I put the identity values. The 45 degree identity triangle is pretty simple. The hypotenuse is root 2, the sides are 1 each. Find the trig value, so we remember that tan theta is opposite over adjacent. So from the 45 degrees here, opposite is 1 and adjacent is 1. 1 divided by 1, you're just going to get 1. Then we've just got to check the sign. So in this quadrant, tan is positive. So therefore, tan 225 degrees equals 1. Now I have the luxury of being able to check that on my calculator, but if you continue with mathematical methods, you will have cases where you do not have the calculator on you. You won't be able to check like that as easily. Make sure you understand it before you find yourself in a test and having to do that. All right, so that's it. Now, year 10, you have been rather quiet. Do remember that you can talk. I am here and probably won't bite you. Bye.